Welcome to Intermediate Algebra, Unit 4, Lesson 1, Introduction to Solving Systems of Equations. We have two lesson objectives in this unit, in this lesson. First, we're going to determine whether a given point is a solution to a two-variable system of linear equations, and then we're going to graph a system of linear equations and determine the solution by finding the intersection. So, what's new here is that up until now we have worked with solving single equations. In this unit, beginning with this lesson, we will work with two equations at a time. Now, this could also extend to 3 or 4 equations at a time, and you would have to have the same number of variables as you had equations. But to introduce the ideas of how to solve these systems, we're going to work with 2 equations and 2 variables. So the 2 equations considered together, where they both have to be true at the same time, are called a system of equations. So the first part is we're going to be given a point and asked to state whether or not the point is a solution to the system. Now when you're given a point before and asked to see if it makes the equation true, you just substitute the point in, and if you get a true statement like 5 equals 5, then you say, yes, this is a solution. Well, this is exactly the same, except you have to check the point in both equations in the system, and they both have to be true. The second thing we will do is we'll be given a system that has 2 lines, and we will have to graph them to find the point of intersection, and this will show us the x and y coordinate that will make both equations true at the same time. So here's the first example. I want you to state whether -1, -4 is a solution to the system y equals 5x plus 1 and y equals x minus 3. So this -1, -4, this is an x and a y. Anytime I'm given a point and my variables are x, y, the first is always the independent variable, and the second is always the dependent variable. First goes with the horizontal axis, second goes with the vertical axis. It doesn't always have to be x and y, but that's mostly what we'll see here. So I take the first equation as y equals 5x plus 1, and I put in -1 for x and -4 for y. Now this is tricky because look, I have the y comes first here, and the y comes first, but in the point the x comes first, so you have to pay attention to what you're doing and put the numbers in the correct place for the variables they represent. So that's what I do. Now I check to see if this is true. Is -4 equal to -5 plus 1? Yes, it is. Now if I were just given this equation by itself, I would be done. But I'm not. I also have to see if this equation is also true at that point. So I have y equals x minus 3, and I put in -4 equals -1 minus 3, and I say, is that true? And that's supposed to be a question mark, sorry. And it is indeed true, so both of these are true, so the answer is yes, it is a solution. And you should always draw your conclusion. You're asked to state whether this is a solution. Yes, it is a solution. Is your conclusion. The equations are your supporting work. I will want to see all of that. Next example. So I have, notice this equation, the first equation is not in slope-intercept form, and is neither is this one. You don't have to have the equation in a particular form for it to be a system, or to solve the system, or to find check for solutions of the system. Again, I have the x is given first, so x is 3, y is -2. And that's what I want to plug in. So in the first equation, I have 3 plus -2 equals 1. That's from this equation here. And I'm checking to see if that's true. So is 3 plus a -2 is the same as subtracting. When you add a negative, the same as subtracting. And I get 1 equals 1. That is a true statement. So that one works. I have to check the other also, though. So 3 times 3, because x is 3, minus 4 times -2 equals 8. Because I'm working with this equation here now, I want to check to see if that is true. 9. -4 times -2 will give me a positive 8. So I end up adding 8. Even though this starts out as subtraction, I'm subtracting a positive times a negative, so I'm subtracting a negative, it becomes addition. Is that equal to 8? No. So 17 is never equal to 8, so this is not a solution. 3 negative 2 is not a solution to the system. And that is an example of your conclusion right here with the type of work to support it that I will need to see. Now, here is the next type of problem we will do in this unit, in this lesson. You're given the two equations. You're given y equals 5x plus 1 and y equals x minus 3. And I want you to find the solution by graphing the two lines and finding the point of intersection. Many students find this, and you have to know how to graph a line by now. You absolutely do. If you're struggling with that, we need to intervene and get you help right now. It won't take long to straighten it out, but you must straighten it out now. So if you can graph lines when they're given in any form, finding the intersection point is pretty easy. So most students like this method, but this method is a little bit limited as far as precision and size of numbers and things like that. So here is what we do. First, we're going to graph the first line, and I've done that here. The red line is y equals 5x plus 1. And then on the same graph, we're going to add the second line, y equals x minus 3. Now what I see is the solution is at the point of intersection. Here is the point of intersection right there. So I read off the graph, the x-coordinate is -1, the y-coordinate is -4. Might be kind of small and hard for you to see, but that is my solution, and the other way we write that is as a point. The solution to this system is -1, -4 in parentheses. Okay, so that is how you do this. Let's move on to more examples. So this one you're going to solve by graphing. Now this is a little tricky for me to do freehand on the computer. I don't know if you're aware of how I do this, but I have an iPad I'm writing on, and it's not that easy to write with a stylus. But we're going to try this one to show you step by step. So I have x plus y equals -1, and I'm going to graph that line first. And some of you are saying, "Well, I don't like graphing lines in that form." Well, let's work on that. So x plus y is -1, x, y. Well, when x is 0, y must be -1. If I put in a 0 here, that means y is -1. And if y is 0, x must be -1. So all I need is 2 points to graph a line. So those are the 2 points I'm going to choose. First 0, -1 for the first one, and then -1, 0 for the second. Now, those are really close together. It might be nice to pick something further out, like x is 3. If x is 3, 3 plus what equals -1? Y must be -4. So I pick one more point just to give me some sanity in checking and give me another line further away to go to when I use my straight edge. I am using a straight edge. You can't see that, but hopefully this will work out with the technology. There we go. That's approximately my line. A little tricky. This last end of it is not great, so we'll do that. Oh, I've erased the whole thing. Let me put it back. There we go. All right, ignore the mark at the bottom. That's for my fingers. So now I want to graph the other equation. I'll do that in red. So I'm going to graph this equation. And again, x, y. When x is 0, I have 0 minus -3y equals -9, so y must be +3 because I get a negative result, so it has to have the opposite sign. When y is 0, x has to be -9. Those are pretty far apart. Let me graph those and see what that looks like. So to see if that helps me with my line, there's my 0, 3. And x is -9, y is 0 is way over here. Now, I am trying to use a straight edge here. Let's see how that works out. Whoop. Here we go. Oh, that was a lousy line. Let me undo that. Sorry, you're going to see me struggle with these a little bit, I think. I keep getting this pop. Here we go. Well, it's a little tough to see that. You have to draw these carefully. I think I drew this blue one a little under. I think that's my result. I can check it. So I think x is -3, y is 2. Solves them both. -3 plus 2 is equal to -1, so it works in that one. And then down here, -3 minus 3 times 2 does give me -9, so my result is x is -3, y is 2. So you have to draw your lines carefully. It's a little tricky on the graph on the computer for me to do that. But you will be able to. You need a ruler. Next example. Solve this one by graphing. 1/3 x minus 3, 1/3 x minus 4. Well, I'm going to graph this one using the slope-intercept kind of idea. So for the first line, we'll do the first line in blue. I start at -3 and I go up 1 and over 3 to the right. It's got a positive 1/3 slope. And I draw my line. Try this freehand. I might do it just as well. Yeah, the ruler doesn't help me much on the computer. It just makes things strange. So the next line, 1/3 x minus 4, well, I'm just starting just a little below. And I go up 1 and over 3. And what you see is I'm parallel. If I draw this correctly, these two lines will never intersect. And we say there is no solution. Because these two lines will never cross. There's not a value of x I can find that plugs into both equations and makes them both true. So if you get parallel lines, and how do we know these are parallel? Well, these are in slope-intercept form, so it's pretty easy to tell. The slopes are the same. If the slopes are the same, they're parallel. And unless, if the numbers are the same, you only have one equation, if the intercepts are the same. But if the intercepts are different, you get parallel lines and there's no solution. All right, let's move on to the next example. Okay, so I have x plus y equals -1, and 2x plus 2y equals -2. So x plus y is -1. I'm again going to set this up x. Let me erase that. X, y, 0. So y is -1, and when y is 0, x is -1. I graphed this line before. I think I decided to use when x is 3, y is -4 is my third point here. 3, -4, and 0, -1, -1, 0. Those are my 3 points. Line is about like that. 2x plus 2y is -2. Oh, I should be doing this in red. Okay, so the second line here, if x is 0, y is 2y equals -2, so y is -1. If y is 0, 2 times x has to be -2. Oh, I get the same points. And if I put in x is -3, I'm sorry, x is +3, I will also get y is -4, because -6 plus 2y equals -2 means 2y will equal -8. Sorry, that's a +6. 2y will equal 8. And 2y will equal -8. Let me speak correctly here. And I will get y is -4. So I have exactly the same line. So because these two are exactly the same line, I should draw that right on top, I actually don't have a system. I really have one equation stated two different ways. If I multiply everything in the blue equation by a 2, I get the red equation. So these are not what we call independent. These are dependent on each other. They can be multiplying one by a number by one of them gives you the other. So there are what we call infinite solutions because every point on the line is a solution and there are an infinite number of points on a line. So that's the other special case. If you come out getting exactly the same line, you have infinite solutions. If they're parallel lines that aren't the same, then you have no solution. Well, I don't know why I lost the slideshow. Let me go back to that. There we go. And we just did this one. And we're going to do that one. So you stop the video and try each problem. So I give you a problem, and then I give you the answer on the next slide. So you're going to have to stop and start for the 3 examples. Here is the first you try it. Graph these and see if you can't find the intersection. Now, these are all contrived to be nice integer answers, and this is where the graphing technique falls apart, is if you don't have integers, it's kind of tricky to tell exactly where you are on the graph, but all of these should end up with nice integers. So solve this by graphing, stop the video, and then come back to see the solution. Okay, so here are the 2 lines, and the solution should be x is -2, y is 4. Let's move on to the next one. Okay, stop the video and try this one. This is on your guided note sheet as well. The solution to this one is x is -1, y is -4, as you can see by the 2 lines. In the final you try it, stop and graph this one, and then come back and check your solution. There's no solution because these lines are parallel. They both have a slope of 8 but different y-intercepts. That's all there is for this lesson. Thank you for joining me in this edition of Math Teacher to Go, and I'll see you next time.